Alright, so this lesson is going to be on comparing functions, the linear, exponential, and quadratic functions from a table, okay? So remember with linear functions, they have a constant. Okay, so we've talked about this before. They have a constant or same difference. So they add the same number over and over and over again, okay? So, but with a quadratic function, we haven't learned this yet, or maybe we talked about it slightly, but we haven't spent a whole lot of time on it. Quadratic functions have constant second differences, okay? And I'll talk about what that means in a second. And then exponential functions have a constant ratio. So this word ratio right here just means multiplying by the same number over and over again. Okay, so let's look at first a linear function. Okay, so let me zoom in a little bit. All right, so for a linear function, for a graph, okay, notice that we're adding the same amount for our x values. So that's going to be consistent through all of these. You should add the same amount for the x values every single time. The y values is where we're going to look at where the differences are. So for our y values, notice we're going up by a consistent number from 4 to 3, or from 4 to 3 we're subtracting 1, or we're adding a negative 1. From 3 to 2 we're adding a negative 1 again, or subtracting 1, and then from 2 to 1 we're subtracting 1 or adding a negative 1. So we're basically adding by negative 1 each time. Okay, so that is our constant, what's going up by the same amount. Okay, we're going to look at more examples in a second, but if we're adding by negative 3 each time, or if we're adding by 4 each time, adding by a constant number, this number's got to be the same throughout for it to be linear. Okay, let's move on to quadratic. Okay, so for quadratic, notice the x values are the same. We're adding 1. Okay, so most of the time we're not really going to even pay attention to this, because hopefully when we are creating a table, we always start with the x values, like them being consistent like this. So we won't really look at x as much. We're only going to mostly look at y. So this time, instead of just doing like we did for a linear function, taking that difference once, we're actually going to do that for a quadratic twice. And if we have the same number the second time we do it, then we know it's a quadratic function. So from 3 to 2, we're subtracting 1. From 2 to 3, we're adding 1. From 3 to 6, we're adding 3. And then from 6 to 11, we're adding 5. Okay, so notice the first difference is not the same. So this is not linear. So we're going to do it a second time and see if we get quadratic. So from negative 1 to 1, notice there's a 0 between these two numbers. So we're technically adding 2 to negative 1. So negative 1, 0, 1, that's plus 2. Okay. And then from 1 to 3, we're adding 2. From 3 to 5, we're adding 2. So since this number is the same, we know it's quadratic. Okay, so that's something new we haven't talked about before. All right, so we're going to move on to exponential. So exponential function is the same. Again, with the x values, we're going to go up by a constant amount. But for our y values, notice if we tried doing linear, okay, linear function from 6 to 18, we're adding 12. And then from 18 to 54, that jumps up by a whole lot, 18 to 54. Y'all help me with the math. This is why I wish I had students with me right now, but I don't. Oh, coronavirus. Okay. No, but basically you can notice we're not going up by the same amount each time. Like we're going up by like 100 and something here. We're going up by like 12 here. So we're definitely not going up by adding by a consistent amount. But if we're looking at this, and if you're not sure, you can always take the second one and divide it by the first. So if I do 18 divided by 6, oh, okay, this is 3. Then, yeah, y'all can see that. Okay, then 54, I could do 54 divided by 18. So I'm just taking the one before and dividing it by the one, or taking the one after and divided by the one before. So 54 divided by 18 gives me 3. And then if I do 162 divided by 54, that'll give me 3. So that's kind of where these times 3 are coming from. It should be a little easier to see than that. Like we're going to have smaller numbers usually, but if you have big numbers like this and you want to divide, that's another way to find whether you're multiplying by the same amount. So notice instead of adding the same amount for a linear function, we are multiplying by the same amount for exponential. All right, so let's look at some more examples. All right, so from 7 to 4, we are subtracting 3, right? And then I would always start with whether I'm adding or subtracting by the same amount because it's the easiest to see. 4 to 1, we're subtracting 3. 1 to 2, subtracting 3. -2 to -5, subtracting 3. Okay, so we know that this is a linear function. Okay? Then we'll move on to this next one. All right, so we're going from 1.5 to 3, from 3 to 6, and from 6 to 12. So if I try to add what 1.5 is to 3, so that would be like another 1.5. If I do 3 plus 1.5, will that give me 6? No, so we know we're not adding by the same amount. But if we look at these two, it's pretty easy to see, oh, 3 is half of 6, and 6 is half of 12, so I might be multiplying by 2 each time. So if I do 1.5 times 2, will that give me 3? Yeah, and then 3 times 2 gives me 6. 6 times 2 gives me 12. So if I'm multiplying by the same amount, this is exponential. All right, then for this last one, you can probably guess what this one's going to be. Maybe not, but we'll double check just to make sure. So from 6 to 3, we're always going to want to try to subtract first or add, but we're definitely subtracting here. So 6 to 3, we're subtracting 3. From 3 to 2, we are subtracting 1. Oh, and then guess what? We're switching now. We're adding 1. And then we're adding 3. Okay, so make sure you're including the sign here when you're doing these, because usually when you're trying to find the quadratic, you're going to have some plus, some minus. Okay, then we'll take the second difference. So from -3 to -1, we're adding 2. From -1 to 1, we're adding 2. And from 1 to 3, we're adding 2. Okay, so notice since that second difference is the same, this is quadratic. All right, so if you would like me to send some more examples of these, I can. Another thing you can do, which I've told a couple of students, that when you're doing IXL, which the IXL you're supposed to do after this lesson is IXL CC2. But what you can do is, if you're not sure, you can actually look, and there's an example problem that's similar to the question that you're actually doing, and that should be helpful, that you can compare the computer's work with your work and kind of help you get through these problems. I've noticed that's really helped for a lot of my students. So if you get stuck, please feel free to email me. I'm here to help. But these are the 2 lessons that we're learning this week. God bless you guys. I love y'all. Miss y'all. Bye.